Hey everyone, we are back with another episode of RoboRequest. You ask, we build. Now this time we are taking on a smart safety challenge, an edge detection robot that avoids falling off edges while navigating on tabletops. A huge shout to Robin or Rohit for this brilliant idea. Keep your ideas coming, your project could be the next. Now let's get into it. In this project we'll use one Arduino, one L298N motor drive to move the robot, one IR sensor mounted facing downwards to detect edges, jumper wires, one screwdriver, double battery holder with switch and two lithium-ion batteries, one USB cable to upload code to the Arduino board, and one acrylic car chassis to mount all components and ensure stability. Now if you want to learn how to assemble a 4-wheel acrylic chassis, click on the I button above. We have already uploaded a detailed video tutorial to guide you step by step. Now let's assemble the circuit first. Place the L298N motor driver on the top side of the chassis. The L298N motor drive here has two output channels labeled as out 1, out 2, out 3 and out 4. Now pick one wire of motor 1 and one of motor 2 diagonally. Insert in output 1 of the motor driver. Then pick the other wire of motor 1 and motor 2 and insert it in output 2. Now similarly connect the motor 3 and 4 to output 3 and 4. Check the double battery holder and paste it here. Insert this red wire in the plus 12 volt slot and tighten the screw. Similarly, insert this black wire in the ground slot of the motor driver. Now fix the Arduino board here. First of all, power the Arduino from the motor driver. To do so, insert one wire from the plus 5 volt slot of the motor driver to the VIN pin of Arduino and insert one wire from GND of motor driver to the GND of Arduino. Now connect the control pins of L298 motor driver to the Arduino. ENA to pin 9. In 1 to pin 3, in 2 to pin 4, in 3 to pin 5 and in 4 to pin 6 and ENB to pin 10. Now mount the IR sensor facing downwards near the front edge of the chassis. Connect it to the Arduino. VCC to 5 volt, GND to GND, out to digital pin 2. Make sure to double check your connection with the circuit diagram. Now our circuit is ready and we need to add the code. Download the code file given in the description below. Open the code file if you have already downloaded the Arduino IDE, otherwise download the Arduino IDE first. We start by defining our IR sensor pin. This tells the Arduino that our IR sensor is connected to digital pin 2. Next, we define the pins of our two motors. Motor A left motor uses pin 3, 4 and 9. Motor B, the right motor, uses pin 5, 6 and 10. The EN1 and ENB pins are connected to the enable pins for controlling speed via PWM. Now in the setup function, we first set the IR sensor pin as input, so we can read data from it. Then we configure all motor control pins as output because we want to send signal to the motors. Now this line initializes serial communication at 9600 baud rate, useful for debugging or monitoring the sensor readings. Finally, we set a random seed using analog pin 0. This is done to make the robot's direction changes truly random each time. Now inside the loop function, we read the IR sensor state. If it returns a low, it means an object is detected. We also print this value to the serial monitor. Now if an object is detected, the robot moves forward at a high speed of 200 using the move forward function. While if no object is detected, the robot first moves backward for a short time. Then it randomly decides to turn left or right. Random 0 to function gives us either 0 or 1. Based on the random value, it either turns left or right at speed 140. Now the delay 400 gives its time to turn before checking the sensor again. The move forward function sets both motors to move forward the given speed using PWM. Move backward function makes both motors move in reverse by changing the direction pins. Now to turn left, the left motor moves backward while the right motor moves forward. To turn right, the left motor moves forward while the right motor moves backward. And that's it. Now you can upload the code to the Arduino, connect the Arduino Uno to your computer using the USB cable, then select port and board in the same menu and select Arduino Uno. Now upload the code by clicking the upload button. And now with everything connected and code uploaded. Now the interesting part. Place your robot on a table, insert the batteries into the holder and switch it on. Your edge detection robot is now active. It will roam freely on the table, but the moment it reaches an edge, it sends the drop and changes the direction automatically. Now, this project makes you understand how sensors and motor drivers work together to make autonomous decisions. I hope you found this tutorial helpful. Thanks for watching our tutorial.